Hey there, this is Penelope. This is just a short video on some crazy fractions. I couldn't quite find any examples of the ones that I did in class this afternoon with the fractions on the bottom without just kind of repeating that one. But I will do some division ones to give you the idea. I'll be back. I'm just going to shut the door. These will all involve division of some sort or another, and some of them will involve more than one fraction, and some of them will involve cancelling. The last one I'll do in this short video will be another example of where I'm saying show or prove that the left hand side equals the right hand side. Okay, so our rule for division is if A over B is divided by C over D, that becomes AB times D over C, which is AD over BC. So this one becomes W over 2 times 6 over W, comes 6W over 2W. Oh, it's not going to be much left if we cancel that out. W divided by W is 1. 6 over 2 is 3. Again, we'll use the same rule. V plus 3 over 2 times 5 over 3V plus 9 is 5 times V plus 3. Now, just a quick look ahead would see that 3V plus 9 can be factorised as 3 times V plus 3, and we can cancel the V plus 3 because it's common top and bottom, and we have 5 over 6. Next example is a little bit harder. V plus 3 over 15 times 25 over. Now again, we should be able to spot that there's a common factor. My dog wants my attention, never mind. And then we can write that as 25V plus 3 over 15 V times V plus 3. Now there's quite a lot going on there. Cancel the V plus 3s. 5 goes into 25 5 times, so it's 5 times 5 over 5 times 3V. We can cancel one of those and one of those, and we're left with 5 over 3V. This question is slightly different in that it is set out as a fraction, so there's nothing to actually do, so we may as well skip to the factorising stage. The top line is going to be x times x plus 8, which would probably signify that one of the factors is going to be x plus 8. And I'm just going to take a guess and then check that the other one is x plus 2. X times x is x squared plus 2x plus 8x. Yep. So I'm done, and now I can cancel out the common factors of x over x plus 2. Similarly for this one, we can factorise the top. Remember, this is the difference of two squares. And then chances are that one of these is going to be a factor of the other, but it's not quite so straightforward this time. I know that my 5x squared has got to come from 5x times x. Now I have to find the factors of -6. That's going to give me something that's appropriate. It could be -3 and 2, 3 and -2, maybe 6 and -1, or -6 and 1, etc. Probably it isn't going to be these sort of ones because it's then not going to cancel. So let's just be fairly sensible about this, and let's go for the top one just first up. Now I'm going to go -3 and then plus 2, and I'm going to check. So that's 10 minus 3, so that's 7, so that one's not right. Whoops, what did I lose there? Nothing. I could also do -2 and 3, So let's try that. And then I've got 15 as my outside. 15 minus 2, yes. So that one is correct. And then now I can cancel x plus 3 with x plus 3. And I'm left with x minus 3 over 5x minus 2. And the last one is going to be a show that, or it could have been a prove that. I'm going to start with the left hand side because I can't really do a great deal with the right hand side. So my common denominator is going to be x plus 2 times x minus 1. A times d would be x minus 1 times 1 plus 1 times x plus 2. Now I'm going to sort that out. On the top line, I'm going to go x minus 1 plus x plus 2. And then on the bottom line, we've got x plus 2 times x minus 1. Be careful that you don't just go, oh yeah, look, I can cancel that and I can cancel that. No, you can't. So now we need to simplify the top line and we get x plus x, which is 2x plus 1 over x plus 2 times x minus 1. And oh dear, it doesn't. So it doesn't equal the right hand side. So all we could say perhaps is that LHS doesn't equal right hand side. All right, thanks for watching.